Hello and welcome to another ADAS calibration video. Today we have a 2023 Honda Passport Trail Sport Edition. It's the all-wheel drive model, and we'll be calibrating the front camera using our ADAS Pro Plus calibration frame as well as our iSmartLink 801 display tablet. So let's go ahead and get started. We'll start by inserting the VCI from the tablet into the vehicle's OBD2 port. And then we'll go ahead and turn the ignition on. And then we'll press ADAS calibration. With the vehicle connected to the tablet, we'll go ahead and select USA. And then we'll go ahead and select on ADAS system scan. So we'll scan the vehicle for any codes. Now for demonstration purposes, this vehicle doesn't have any codes at this time, but we'll move forward as if it did and calibrate the front camera. With the scan completed, we'll go ahead and generate our pre-repair report. So we'll click on the report button. Our report type says pre-repair. Here we can add a work order number, customer name, any additional information that we might want to include with this report, as well as attaching photos. So I'll go ahead and click OK. And this generates our pre-repair. We'll save it. And next we'll go ahead and click on the ADAS calibration function, and we'll choose lane departure warning front camera calibration. We'll choose static camera aiming. Now this vehicle requires both static and dynamic, so we'll complete the static portion, and then after we'll have to go for a drive to complete the dynamic portion. Next we'll be asked which frame type we're going to be using, and again we're using our ADAS Pro Plus, so I will go ahead and select that. And next we're going to go ahead and click on Setup, and we'll get the frame all set up ready to calibrate. So the first thing we want to do is set the frame to its default state. There are 3 fine-tune adjustments that are made on this. So we'll start with the fore and aft. Can adjust the frame to go forward and backwards, so we'll set that right in the middle, which is our default setting. We can also change the pitch or the yaw of the frame, and that's done with the knob here on the left-hand side. So we'll set that to 0. And we can change the parallel side-to-side motion of the frame, so we'll go ahead and adjust that. All right, and we're ready to move on to the next step. So the next step is to go ahead and install the wheel clamp and ranging panels, so we'll do that. Here at the rear of the vehicle, we're going to go ahead and place our rear wheel ranging panels. So we'll just clamp this onto the rear tires. We'll tighten that up snug. And the main point here is to go ahead and make this vertical. There's a bubble indicator located right over here. And that's it. Next, we'll do that on the driver's side as well. But we'll also need to set our distance ranging panel. And this panel will be placed right at the front hub center. And that's going to be used for our distance measurement. With the ranging panels all in place, the next step is to go ahead and install and turn on our central laser. We'll also turn on our distance range laser, which will point to the front hub here. And we'll move our frame to 6,000 millimeters from the front center hub. So currently we're at 2,000 millimeters, so we have a ways to go back here. On these Hondas, they're quite a distance from the vehicle, so we'll be back here at 6,000. And there we are at 6,000. So we'll go ahead and straighten out our frame, confirm our distance, and we'll move on to the next step. So next we're going to go ahead and make sure that our frame is level. Our ground here is quite level, so I'm looking at our bubble indicators here, and we look good there, so we'll move on to the next step. So next we're going to go ahead and make our yaw adjustment to the frame. So we'll be turning on our 2 rear range panel lasers. We'll set that one. And the other one here on the driver's side. And currently we are about 8 meters, and we need to fine tune it so that they're equal on both sides. So it looks like we're going to be turning it this way, pitching it to the left. And we're going to land here at about 88.25. Okay, just double check here. Yep. All right, so we'll move on to our next step. Now with that adjustment made, we need to go ahead and center our frame again. So we're a little bit off from center. So I'm just going to slide it over to the right. Get ourselves centered. And we'll make sure that we're still parallel here. $88.45. All right, so we are center. Gonna go ahead and make a little bit of adjustment. All right, and we'll go ahead and lock down our casters so that the frame doesn't move anymore. So just to recap what we've done here, we've made sure that our frame is center, that our pitch is equal on both sides, and that our distance is 6,000 meters. So 6,000 millimeters. So we'll go ahead and move on to the next step. Okay, the next step is to go ahead and adjust the height of the frame. So the specifications calls for 1180. So we'll turn on our height laser, and we'll go ahead and set the frame to 1180. Okay, we've got that. And next we'll go ahead and place the target. The target for this particular Honda is the LAM01-20. It starts off in the center, and then we'll move sequentially to the left and to the right, or driver and passenger. So let me go ahead and get that started. So with the calibration frame all set up, next is to place our target. This target will be placed in the center here, so we'll go ahead and turn off our central laser. We'll go ahead and remove it and set it aside. Next, we'll go ahead and place the target. And we'll go ahead and start the first part of the calibration. So I'm going to stay behind the back of the camera here, and we'll go ahead and click on calibration. Now we'll need to enter some values into the tablet. It is the average measurement of the left and right side, or driver and passenger side, front wheel arch. I've measured them already, and they are approximately 840 millimeters. So I'll go ahead and enter that value in. And the standard value is 834, so I'll enter that. And then we'll move on to our next step. So we have a successful calibration of the target in the central or center state. The next step is to go ahead and put the target over into the driver's side or left side. So we'll be moving that back over to the target frame. We'll need to set the sliding block to 800 millimeters because we actually have to extend the target farther out. So we'll go ahead and attach the extension frame to the sliding mount. We'll slide on the locking collar. Again, making sure here that we're set to 800 millimeters on the sliding block. We'll then take our target, move it over here, and place it on the left side. And then we'll go back and stand behind the camera again. We'll go ahead and click Next. We have a successful calibration on the left or driver's side. So we'll go ahead now and move the target to the passenger side. As well as the extension bracket. We'll place that on here. Attach the locking collar. And place the target. We'll come back over to the vehicle and stand behind the camera. We'll click next. And we have a successful calibration for static. So I'll go ahead and hit OK. It's asking to cycle the ignition, so I'll go ahead and turn the ignition off. And go ahead and press OK. Cycle the ignition back on. And press OK. So this completes the static calibration portion of the calibration steps. We'll now need to move on to the dynamic, which is the driving portion. So we'll get ready to take this vehicle for a drive. So now we're ready to do the dynamic portion of the calibration. So here the prompt of the tablet is asking me, are we ready to perform the dynamic calibration aiming? So I'm going to go ahead and hit OK. And this is just telling me that this function needs to have a running vehicle. So we'll go ahead and hit OK. All right, and then it's just letting me know to make sure I drive on a straight road that's flat, that has parallel lanes, well defined, and to keep my speed between 45 and 70 miles per hour. So I'm going to go ahead, and I've got the engine running already. I'm going to go ahead and press OK. And you can see here it says dynamic camera aiming now in progress. Keep driving until it is completed. So I'm going to go ahead and start driving. And we'll keep an eye on that, but we'll focus on the road. Okay, so we have a completed calibration. We'll go ahead and bring the vehicle to a stop. We'll go ahead and press OK. And we need to cycle the ignition, but I cannot do that right now. So we'll go ahead and pull over to the side of the road and we'll complete the next step. So we're here pulled over safely to the side of the road. So I'm going to go ahead and put the car in park. We'll go ahead and turn the ignition off. We'll click OK on the tablet here. And then we'll go ahead and cycle the ignition back on. Press OK. And we'll go ahead and create our ADAS completed report. So we'll hit OK. Hit OK again. This completes our diagnostics report, showing both the dynamic and static calibration was a success. We'll save that report, and then we'll go ahead and combine that with our pre-repair. So we'll change our report type from pre to post. We'll click add in the pre-repair as well as the diagnostics report, so that we have a combined report in our post. So do that, say OK. If you're having to bill insurance, you can populate that information here. And here we have our completed report with both the pre and post repair and diagnostic scans. So we'll save that and we'll close out of this session. So this completes the forward camera calibration on a 2023 Honda Passport Trail Sport Edition. Again, this is both the static and dynamic calibration. It has to both be done. Static first, then dynamic. So we hope that you found the video helpful, and we look forward to seeing you at the next one. Bye for now.